Good afternoon, everybody. Welcome back to lecture 42. Today we will have a very short lecture. Please make sure to solve the last fake quiz number 4, or the 8th quiz. And this is the formula. So last time we talked about the variable reluctance stepper motor, correct? Did we explain the half? The half angle?
No.
So last time we talked about the full angle. Basically you have, for full step operation, you only have one coil active at a time. So you have here ones. Every time you add 30 degrees because of that movement. If you want to do the half step operation at even steps, 2, 4, 6 even steps, you have 2 coils that are on. Then you get the 15 degrees. Okay, can I have, and let me ask you a technical question. كيف لو أنا خليتها always 2 coils on? This is conceptual question. I skip الodd 1 و 3 و 5. يعني أبدأ هنا 2 بعدين أسوي 2 بعدين أسوي 2. Now I'm having 2 windings active at all the time. I will go back to full step, but I will have very high current. So this is one different operation that's not mentioned. Maybe I'll bring it in the exam. Let's call it the double coil full step operation. If I skip 0, 1, 0, skip 0, 0, 1, I only have 1, 1, 0, 0, 1, 1, 1 zone, 1, 0, 1. Then I'm going to have higher torque because I'm putting more current in the coils. But I still get the 30 degrees. So this is one type of operation. So you're not only limited with the full step and half step. You can have your own using power electronics. Using your power electronics. These are the equations. So to reverse the motion direction, the sequence of pulses has to be changed from 1, 2, 3 to 1, 3, 2. To reverse the direction, you just have 1, 3, 2, 4, 6, 5. Get it? You have 1, 3, 2. So 1, 0, 0, 0, 1, 0, and then 1, 1, 0. Or if you have full step, you start with 1, which is 1, 0, 0, then 0, 0, 1, then 0, 1, 0. If this is coil 1, coil 2, coil 3, it's like having A, C, B. نفس الphase sequence. Clear how to reverse the motor operation? So we have reverse operation, we have double coil full step operation, we have half step operation, we have full step operation. The floor is yours depending on the tables. Okay, do not memorize the tables, understand them. For the full step operation, only one coil is energized at each step. To operate in half a step, we need to follow the following sequence: 1, and then 1 and 2, and then 2, and then 2 and 3 coil, and then 3, وهكذا. And clearly the half step angle is half of the full step. So if the full step angle using this equation is 360 over, what was the equation? The equation. 360 times the difference between the number of teeth over the multiplication between 30, the half step is 15. Okay? Now half step has drawback of pulsating torque. This is the only downside, and it is very important. Half step has drawback. Why it has a drawback? Let me explain it. If you start with the problem with it is if you have step 1, 2, 3, 4. هنا كم كان؟ 1, 0, 0, 1, 1, 0. The half step. 0, 1, 0, 0, 1, 1. Let's say the torque. The torque here due to 1 or 2 coils?
1.
1 coil. So the torque will be here. Here, the torque is due how many coils? 2. So it will be higher. Here low, here high. What is the equivalent? Low, high, low, high. Get it? But torque will have variation. This is what we call ripple. That's a ripple. Or we call it pulsating torque. This is a very common thing if you have the half angle operation. Is it clear?
Yes.
Another thing we want to discuss is there is something called the steps per revolution equal to 360 over the angle. Basically 360 over 60, how many steps you have? 360 over 30? 6 steps. Over 15? 12 steps. So sometimes people call it 12-step operation. The 6-step operation. That's it. The motor speed in RPM is 60 F over S, where S is number of steps, frequency is the number of pulses per second. This has to do with the power electronics. We do not have a numerical example in the slide, but depending on how many pulses that arrive from the power electronics and number of steps of your operation, you can get the RPM. The drawbacks of the variable reluctance that smaller torque compared to permanent magnet or hybrid. If you have a permanent magnet, you get a flux from the magnet and flux from the coils. If you don't have a permanent magnet, all of your flux is from the coils. Does it make sense? So a permanent magnet acts like a booster for the flux. And there are some critical steps, for example, 1.8, 5, 7.5, 15 degrees. In our example, we had 30 or 15 degrees because it's easier to operate. But if you have very long tables, if you have, for example, 5 degrees, you'll have very long tables. And you need more switches. How this is achieved? How the power electronics look like? Let me ask you a question. How many teeth in this machine? The stator.
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. How many phases do I have? Does it have to do with number of teeth? No. It has to do with the letters. A, B, C, D, plus some minus. How many phases? It's a 4-phase machine. Remember, this is a DC. 4 different DC supplies.
We count the plus and minus, or?
And plus or minus is 1 phase.
Oh.
Okay? So, how many tooth in the rotor? 6. So this is a this is an 8 by 6, 4-phase stepper motor. Clear? What is the step angle? 360 times difference. 8 ناقص 6 2. 8 في 6 48. What's the step angle? 15? Correct. 15. That's full operation. So if you do half operation, it will be 7.5 with the pulsating torque, but we're not going to discuss it. Now, using the power electronics, what will happen? No, the lecture is over. What will happen is you connect all the phases for a resistor for protection to IGBTs, MOSFETs, or IGBTs, whatever you choose. And then you connect each one of the coil to the supply. And here you send your pulses, A, B, C, D. So this is the 4 phases, but you send 4 control signals for every phase. All of them are DC. This is not 3-phase AC. Any phase is a coil. There's a coil, there's a coil, there's a coil. And you send the 4 control signal, 100, 101, through this power electronics. So in the next lecture, we're going to talk about the torque. The main reason here, if you distribute your coils across, if you have double coils, they have double coils, you will have more torque compared to if you have all your coils in one tooth. We'll talk about that next lecture.